Hello viewers, welcome to add-on. In this question, we are asked to convert the following binary codes into gray code and its XS3 code. So let us start with the conversion process. So at first, the conversion technique of a binary code to gray code, I will explain it first. So let us consider any binary number like 1100. Okay. So if we want to convert this binary number into its equivalent gray code, the first process or the first step will be we have to write the most significant bit, and in this case the most significant bit will be the bit which is present on the absolute left hand side. So here in this binary code the most significant bit will be this one which is written on the absolute left hand side. So we will just write it 1, and after that we will XOR get the adjacent bits. Like for this to 1 we will XOR get it, for this 1 and 0 we will XOR get it, for this 0 and 0 we will XOR get it, and the result of this XOR gets are just written side by side to this one. Okay, so if we are considering this example, so we have written the most significant bit at first, then we need to XOR get the adjacent bits. So 1 XOR 1 will be equal to 0, then 1 XOR 0 will be equal to 1, and the 0 XOR 0 will be equal to 0. So this will be our gray code. So this is the conversion process of a binary code to gray code. And for XS3 code, we just need to add 3 to the binary code which is given to us. Like if we take this example 1100, if we want to find this XS3 code, we just need to add 3, which will be equal to 0011, because if we take a binary number, for example this binary number 1100, at the absolute right hand side it has a positional weight of 1, after that it has a positional weight of 2, after that it has a positional weight of 4, after that it has a positional weight of 1, positional weight of 8, and the positional weights will grow like this: 2 to the power 0, 2 to the power 1, 2 to the power 2. Likewise, as the binary number grows in length in the left hand side, the positional weight will increase likewise. Okay, so we need to understand it, and if we want to determine the value of any binary number, we just multiply the bits which is positional weights, and we will add them together. Like in this case, if we want to find the value of this binary number, we will multiply 1 with 0, 2 with 0, 4 with 1, and 8 with 1, and then we will add it together. So in this case our value will be, this 2 multiplication will be 0, because 1 into 0 will be 0, 2 into 0 will be 0. So here we are getting a value of 8 into 1 plus 4 into 1. So we will be getting 8 plus 4, which is equal to 8 plus 4, 12. Okay, so this binary number has a value of 12. So we can easily do the math now. So we have to do the binary addition in this case. So the rules of binary addition are quite simple. 1 plus 0 will be 0, 0 plus 1 will be 1 plus 0 will be 1, 0 plus 1 will be 1, 1 plus 1 will be 0 with a carry of 1, and 1 plus 1 plus 1 will be equal to 1 with a carry of 1. Okay, so the rules are simple: 1 plus 0 will be 1, 0 plus 1 will be 1, 1 plus 1 will be 0, and 1 plus 1 plus 1 will be equal to 1 with a carry of 1. And in this case we are also getting a carry of 1. So if we do the binary addition in this case, we will be getting 1 1 1 1. So this is our XS3 code, and we can also check if it is a XS3 code or not by checking its value. Like we have determined the value of 1100 as 12. So if we add 3 to it, we will get a value of 15, right? So here in this case we will get a value of if we multiply the uh, positional weights with the bits they are associated with, we will get a value of 8 plus 4 plus 2 plus 1, which will be equal to 8 plus 2 is 10 plus 1 11 plus 4 equal to 15. So yeah, if we add 3 to it, we will get a decimal equivalent of 15. So for binary case, so if we add 3 to this binary number, we will be getting this binary code, which will be the XS3 code. Okay, so this is the basics of it. So let us start with our 3 example which are given to us. So for 1011, at first we write the most significant bit 1, then we will XOR get the adjacent bits. Okay, so 1 XOR 0 will be equal to 1, 0 XOR 1 will be equal to 1, and 1 XOR 1 will be equal to 0. So this is our gray code for this binary number. And for XS3 code, 1011 plus 0 0 1 1. We will add 3 to it. So 1 plus 1 will be equal to 0 with a carry of 1. Then 1 plus 1 plus 1 is equal to 1 with a carry of 1. So we are getting 1 with a carry of 1. Now 0 plus 0 plus 1 will be equal to 1, and 1 plus 0 will be equal to 1. So the XS3 code will also be 1110. Okay, so this is the XS3 code. So as I have said earlier, we can check the value of it. So here 1011 have a value of 8 plus 2 plus 1, which is equal to 11, and in this case this has a value of 8 plus 4 plus 2, which is equal to 14. So 11 plus 3 is equal to 14. So yeah, this is our XS3 code, and in this case I have also guessed that everybody can understand it. We are writing the MSB, and then we are XOR getting the adjacent bits, and we are writing the result. So 0 XOR 1 will be equal to 1, 0 XOR 1 will be equal to 1, and 1 XOR 1 will be equal to 0. And if anybody has problem understanding it, the rules of XOR get it. 0 XOR 0 will be equal to 0, 0 XOR 1 will be equal to 1, 1 XOR 0 will be equal to 1, and 1 XOR 1 will be equal to 0. So these are the rules of XOR gate. So for the next example, 1 1 1 1. So if you want to write is gray code, at first write the most significant bit 1, then XOR get this to adjacent bit, we will get 1 XOR 1 0, then we will XOR get this to adjacent bit, we will get 0, then we will XOR get this to adjacent bit, we will also get 0, because 1 XOR 1 will be equal to 0. And now for the XS3 code, we will just add 3 to it, 0 0 1 1. So 1 plus 1 will be equal to 0 with a carry of 1, 1 plus 1 plus 1 will be equal to 1 with a carry of 1, 1 plus 1 will be equal to 0 with a carry of 1, 1 plus 1 equal to 0 with a carry of 1, and we will write the carry here just like this. Okay, so this is our equivalent number. Now if we want to verify it, so this binary number has a value of 8 plus 4 plus 2 plus 1, which is equal to 8 to 10 11 15, and this binary code has a value of, we have to notice that this is a 5-bit number and this is a 4-bit number. So for 5-bit number, for the most significant bit, as I have said earlier, the positional bit will increase, like 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Here this is the 5th bit, so it has a power of positional bit of 2 to the power 5. Okay, sorry, 2 to the power 4, which will be equal to 16. So this is the value of 16, so we are getting 16 plus, here it is 2, which will be equal to 18. So yeah, 15 plus 3 is 18, so our result is correct. And for the next binary number 0 1 1 1, we will write the MSB at first to convert its gray code, which will be 0. Now 0s or 1 will be equal to 1, 1s or 1 will be equal to 0, and 1s or 1 will be equal to 0. So this is our gray code. And for the XS3 code, 0 1 1 1 plus 0 0 1 1, this will be our XS3 code. So 1 plus 1 will be equal to 0 with a carry of 1, 1 plus 1 plus 1 will be equal to 1 with a carry of 1. Now 1 plus 1 will be equal to 0 with a carry of 1. Now 1 plus 0 which will be equal to 1. So this is our XS3 code. And if we want to verify, this has a value of 8 plus 2, which is equal to 10, and this code has a value of 4 plus 2 plus 1, which is equal to 7. So 7 plus 3 is equal to 10. So yeah, our answer is correct. So this is the total conversion process for gray code and XS3 code. Thank you.